Hi guys, I hope you guys are all safe. I'm sorry for the delay in this recording. We've just had some technical difficulties. I think the last one we ended in number 20. So I'm gonna go ahead and continue on number 22. If you guys have any questions, you guys know how to reach me. You can text me or you can email me. I'll be uploading this video and all of the other ones that I've recorded on Blackboard and also on a webpage. So I'm going to go ahead and get started here with number 22. It says consider the following values. Are the values 0 and 250 declared outliers using the classic outlier detection rule? So we're going to go ahead and start by putting all these variables into that x. So x combine, is on the drill, 20, I'm sorry, wrong one, 0, 121, 132, 123, 145, 151, 119, 133, 134, 130, and 250. We want to see if it's going to mark 0 and 250 as the outliers because they're the ones that are, the biggest differences. So to use this one, it's going to be that classic outlier rule, which is the outmost. And okay, so I have to download it again because it erases every single time that I close the program, so I have to re-download the package. So hold on a second. I think maybe it's already here. Yeah, it's already here. Okay, so I'm gonna go ahead and just do file. Oh, sorry, source file.choose. Okay, so I'm going to press enter here and it's going to bring me to that window and it's going to download all of that. So now I should be able to use that function x, and there it is. Okay, so here it's telling you these are the values that are going to get excluded. Out value 0 and 25, so it did mark those as outliers. Okay, so for the next one, number 24. Again, consider the following variables. Verify no outliers are found using the classic outlier detection rule. Hold on a second. All right, so this next one, number 24, again, we're going to do x equals combine 20, 121, 132, 123, 140, 145, 151, 119, 133, 134, 240, and 250. Okay, enter. All of these are saved, so it's telling us again use that classic outlier rule. So again, it's the outmost, I think. And it's going to tell you here the number of values. It tells you which ones are out, so it didn't exclude any of them. So it's telling you keep 1 through 11, which means it kept all of those. So that one didn't mark them as outliers for that one. All right, so then I'm going to skip number 26 because it's not a computational question. It's just asking you to, what is the difference between the box plot rule and the classic outlier detection rule for detecting outliers. Okay, so number 28, for the observations below, verify that the sample mean, 20% trim mean, and median are 33.33 in the following. So we're just going to verify that those are the numbers that we get. So first it's asking to do these ones. So we're going to combine all of these values, 21, 36, 42, 24, 25, 36, 35, 49, and 32. Enter. And so now it's asking to verify the sample mean. So we're just going to do mean x. That should give us 33.33, so that's correct. And then it's asking us to do the 20% trim mean. So it's, I believe, t mean x, just the way that the formula is. That's true for, we're going to do 20%. So this one you can actually just change it to any percentage, but we're doing 20% here. So that one should be 32.85. 32, yes, so that one's correct. And then the median, which is the simple median equation, median x, I'm sorry. Okay, so that one should give you 35. Yes, okay, so that one's right. Okay, now for the next one, it's also not a computational problem, so I can go ahead and skip that one for you guys. Now for number 32, it says for the following observations, verify the sample mean. Again, the same thing. We're just going to verify these values. So again, x is equal to combine the following values, which are 6, 3, 7, 6, 5, 8, 9, 8, and 11. 6, 3, I think I'm missing a 2. 2, 2, 7, 6, 5, 8, 9, 8, 11. Okay, so enter. And now again, we're going to do the same thing, the same functions. So first it's asking for the mean. So mean x. So that's 6.5. So that's correct. And then the 20% trim mean. So again, t mean x comma tr is equal to, we're setting that at 0.2. And it should give us 6.66. Yeah, it rounded up to 67. And then that median again, median x, and that gives you 6.5. Yes, okay, so that's correct. And now on to the next one. A class of 4th graders were asked to bring in a pumpkin to school. Each of the 29 students counted the number of seeds in their pumpkin, and the results were the following numbers. Using R, compute the sample mean, trim mean, median, and mom. So again, the same thing. We're just going to go ahead and I think we're going to use these numbers one more time earlier. So I'm just going to set it as something else. I'm going to do A. I'm just going to change the name of the variable. I'm doing the same thing. A is equal to combine all of these values. So I don't want to replace it with another x, and I'm going to be using x again. So 250, 220, 281, 247, 230, 209, 240, 160, 370, 274, 210, 204, 243, 251, 190, 200, 130, 150, 177, 475, 221, 250, 224, 163, 272, 236, 200, 171, and 98. Okay, our numbers. So now it's saved there into that A variable. So now that I'm going to do the sample mean, I'm just going to do mean, and instead of A, instead of X, I'm just doing A. So that gives you the sample mean for that one. sample mean, and then it says the trim mean, so T mean A, comma, TR as in true, and 20%. So that's 220, and it's asking for median, so median A, 221, and then it's asking for mom, which I think is just mom X, or mom A in this case. Mom A. So that gives you 214.12. Right, so we can move on to the other one, 36. For the observations in the previous problem, use R to verify that the 20% winds rise variance is this one. So I'm just going to go ahead and use the data from the previous question, which is number 35, is equal to we're combining 21, 36, 42, 24, 25, 36, 35, 49, and 32. Okay. So it's asking us to do the 20% winds variance. Okay. So that one, if you just think it's, yeah, here, winds variance. That one is in page 44. So it's basically the same thing. This is the way that you write it down. It's win, and it's the same thing. So we're going to do X. It's true at, they're asking for 20%, so it's 0.2. So we got 7. Use R to verify the 20% winds rise variance. Oh, variance, I'm sorry. We did the standard deviation. So that one is win var X comma TR is equal to 0.2. There you go. So it's 51. That one's right. Okay. So then now for the next one, that one's it's not a computational problem. So I'm going to go ahead and skip that one. And we're going to do number 40. So consider again the number of pumpkin seeds given in the previous exercise in 34. Compute the 20% winds variance. So this is why I saved it in another one, because I knew we were going to replace that one. So we can just do it's winds variance. So we're going to do that, A, comma, TR is equal to 0.2. And that's what we get. Okay. So that is it for this, the rest of the chapter. If you guys have any questions about it, or if you didn't understand something, just go ahead and text me. I'll be available here, and I'll hope to see you guys on Monday.